Hello again. So lung cancer has long been the leading cause of cancer death, and chest X-ray was one of the first imaging modality used for lung cancer screening, especially for high-risk population. During 1950s to 1970s, organizations like the American Cancer Society actually recommended annual chest X-ray screening for smokers. And then later on in the 1960s to 80s, there were multiple randomized trials that study the effectiveness of chest X-ray. So here are four key randomized control trials looking at chest X-ray in reducing lung cancer mortality. The first three are in US here, and all of them, the studies were carried out in 1970s to 1980s. And you can take a look at the sample size that they have. Majority of them have a total of almost 10,000 participants with about 5,000 participants in each arm. So what did they find? First, when they look at whether any of these trials reduce lung cancer mortality, none of the trials show that there was a lung cancer mortality benefits. But when they look at whether chest X-ray actually find more early stage lung cancer, they all found that chest X-ray actually can find more early stage lung cancer. So all these studies shows that there's an improved stage at diagnosis. They find more early stage lung cancer and increased survival. And there's a high incidence of lung cancer in the screening arm compared to the control arm. But they found no reduction in lung cancer mortality. So they were saying that even though that they're finding more early stage lung cancer, but it didn't translate to lung cancer mortality. That was the conclusion. So among these four trials, the Mayo Lung Project was actually the most widely cited among the four. It was conducted in the US. And because of this, the American Cancer Society actually withdrew their support for chest X-ray for lung cancer screening in the 1980s. So these studies actually raise concerns about biases and overdiagnosis, and a lot of follow-up studies have studied these randomized control trials. They have pointed out certain issues about these trials, how they might potentially dilute the effects of chest X-ray, pointing out that there are contamination, non-adherence. And one of the issues that people point out was that there might be overdiagnosis in these results, in these cancers that chest X-ray found. And this is an article written by our group. Dr. Y was the first author. In this article, we looked at all the cancers that were from the Mayo Lung Project and MSK, the Memorial Sloan Kettering trial, and we look at the volume doubling time of these cancers. Any cancers with a volume doubling time of greater than 400 days was a proxy for overdiagnosis. And we found that the median doubling time in the Mayo Lung Project was 101 days, and for the Memorial Sloan Kettering was 144 days. And therefore, only 5% of cases in both studies met our criteria for overdiagnosis. So we conclude that the data did not support the claim that frequent overdiagnosis in the chest X-ray screening for lung cancer. So because of all the previous trials, they were saying that all these trials the sample size were relatively small and with potential contamination and dilution of the effects. So they decided to have a much larger randomized control trial. And the POCO studies started in 1993, was designed to study the effectiveness of chest X-ray for lung cancer screening as part of the study. So they enrolled over 77,000 participants in each arm, and they followed these participants for over 13 years. And what they found was, again, no significant difference in lung cancer mortality. And as a result of that, again, it was considered as a confirmation that chest X-ray screening is ineffective. So as a result of these randomized control trial and all the evidence, here is the current guidelines on lung cancer screening. You can see that the top four major organizations in the US, they all recommended low-dose CT screening as a modality for lung cancer screening, screening high-risk smokers. And in all these six major society, none of them recommend chest X-rays as a modality for lung cancer screening. And I want to point out is that Japan is actually, they started nationwide chest X-ray screening in 1987, offering annual chest X-ray screening for adults aged 40 and older. And the latest guideline, they did not endorse population-based CT screening for lung cancer. Instead, low-dose CT screening is available for their population and increasingly being used, but is on a voluntary basis. So we want to look at what type of nodules that can be found on chest X-ray. Here we show that the typical size of nodules found on symptom-prompted cases was between 4.5 to 6 centimeter, and that's the largest. And later on, if you look at chest X-ray screening, the nodules that they can find is typically between 2.5 to 3.5 centimeter, and for CT is 1 centimeter to 1.5 centimeter. So for chest X-ray, even though it cannot detect tumor as small as CT, but it's already much smaller when you wait till symptom prompted. And when we look at the I-ELCAP data in 1999, the Lancet article that we published, and also the NLST data published in the New England Journal of Medicine in 2011, we can both see that chest X-ray arm, the average tumor size was greater than the CT arm, and the percentage of stage 1 was lower in the chest X-ray arm compared to CT arm. But I want to point out that even though the percentage of stage 1 was around between 50 to 60%, but compared to the SEER database, it was only 15%. So it's still higher, much higher than the SEER database. So I have to talk about the relationship between tumor size and survival in the earlier talk. And here, in this paper, they talk about the survival rate for chest X-ray arm in the NLST compared to the CT arm in NLST for the stage 1 lung cancer, and then compared to survival in the SEER database. What they found was the 10-year lung cancer specific survival in the CT arm was greater than the chest X-ray arm, and both of them were greater than the SEER database. So therefore, CT is better than chest X-ray, but chest X-ray is also better than usual care. So lung cancer is highly fatal when diagnosed after symptoms appeared. When we find an early lung cancers and followed by timely treatment, resected stage 1 lung cancer can have higher than 90% lung cancer survival rate. And we know that if left untreated, stage 1 lung cancer have very poor prognosis. In our I-ELCAP paper, we found that all participants who left untreated, they died of lung cancer. So the smaller size we can find a nodule, the earlier the stage, and therefore higher likelihood of cure. So in summary, the historical randomized trial showed no mortality benefits with chest X-ray. CT is now the recommended modality for lung cancer screening because you can find smaller nodule, but chest X-ray can still find more early stage lung cancer than usual care. With the advancement in AI, chest X-ray performance we expect to improve and may enhance early detection for when CT is limited. And chest X-ray is affordable, is widely available in a lot of countries, and its integration into the public health programs. For example, the TP screening and the TP clinic offer a practical pathway for lung cancer screening, whereas low-dose CT is not yet feasible. In conclusion, low-dose CT remains the gold standard, but chest X-ray may still have a role in resource-limited countries.